Greetings to everyone. This is Luandile here, the leader and the instructor of Manuko School. Today we're actually going to be doing the very last exercise, the very last tutorial on this exercise, which is exercise 2.10. That is to say, we're going to be doing it from students' perspective. A student who's considered as the cleverest among all students we have, since we all know we have student A, student B, and student C. So without any waste of time, let's actually create the class itself. So we're going to call it exercise 2.10C. It simply says it's from students' perspective. Okay, what else we want to do is to remove this generated comment, and then what we do is to simply go to the question itself. Okay, so here's the question. Again, this is the textbook we're using in case you did not know, and its link is actually above the main method on the tutorial on exercise 2.9. So let's try to read the question. It's actually science, so we're actually calculating energy. So what we are required to do is to write a program that calculates the energy needed to heat water from an initial temperature to a final temperature. Your program should prompt the user to enter the amount of water in kilograms and the initial and final temperatures of the water. The formula to compute the energy is Q is equals to M multiplied by final temperature minus initial temperature multiplied by 4,184. So we are told that where M is the weight of water in kilograms, temperatures are in degrees Celsius, and energy Q is measured in joules. So here is a sample run. Okay, here in this case, the program actually prompts us to enter the amount of water in kilograms. We put 55. We also are required to enter the initial temperature. We simply put 3.5, and then we are prompted to enter the final temperature, which we decided to make as 10.5, as we all can see. So here's the results of our program. So right now it's time to jump on to our IDE. As you guys can see, we've already created a class, call it 10.C. So now question, so what is it that student C, because we see that student B realized that a program has to have descriptive names for variables, right? Okay, so what student C noticed is that not everything is well commented from student B's solution, and on top of that, there is a variable that was actually used unnecessarily. We could have avoided that variable. As you guys know, that programs, they actually get stored in your RAM. So the more you have tons of variables, the more you're actually going to be occupying your RAM. So it is strongly recommended that you avoid having variables unnecessarily. Of course, modern CPUs and modern computers actually, you don't have to care much about variables when you actually do programming, especially on languages like Java. You see, in C++, you really have to care about how you declare your variables. Anyways, So what you do here is to simply, what we gotta do here is to simply get started with our solution. So we have to create a scanner, do read user input. So we're simply going to go scanner equals to new scanner, and we go system.in. So we simply go scanner, close our scanner. Actually, we need to make sure we close our scanner once we done with it. Okay, what else? So what we do here is to simply declare our variables, call them water weight, comma, initial weight, okay, initial temperature, initial temperature, and then finally we're going to have our final temperature. Why can I spell temperature? Okay, as you guys know, since we have these variables, we can actually put them in one line and separate them by a comma because they all are of the same data type. Okay, what else we gotta do? Oh, we also can put energy needed because it is also of type double, energy needed. With that out of the way, it is actually time to prompt the user to put this, to actually initialize. It is time. Okay, let me just go system.out.print. Now that we've got these variables, we can simply prompt a user to enter. Let's just go enter the amount of energy needed. We don't have to specify in joules because what's the point? Okay, now it's time to initialize our variable. Just go oh, we haven't yet. Oh, we did create a scanner, so we can initialize our variable thanks to these modern compilers, because you can simply put a dot and then everything will simply pop up for you without having to actually type the whole thing. Okay, what else? We gotta go system.out.print, and then we simply prompt the user to enter the initial velocity. Oh, why do I keep saying velocity? Initial temperature, temperature. Guess I've been working on a bunch of physics problems and I cannot get over the term initial velocity. Okay, what else we want to do is to go, okay, now that we have this, enter the initial temperature, we gotta store that on our variable called initial. I misspell this. Let's just go initial. As you guys know, it matters how you name your variables, because you see, giving something that is not descriptive, it's actually hard for other programmers to actually go through your solution and easily get a feel of it. You wouldn't want to come up with something less descriptive. Because as you can see, I just renamed my variable Like I actually wanted to make it initial velocity. However, I made a mistake. I did not put an A, but I decided to rewrite that again. Anyways, let's get going. Initial temperature is actually equal to scanner dot next. Why do I go next line? I thought it's going to pop up and simply give me a next double. There we go. Okay, finally we have got to read the final temperature. Okay, or we can simply copy and paste this and simply change this from initial to a word final. Okay, and again we gotta put the word final. Temporary. Why am I having an error here? As you see, you guys, it really matters to me how you actually display, how you actually name your variables. Because you see, that's the main mistake that beginners usually do. That is to be unable to properly name your variables. Anyways, it's time to wrap it up. You're going to simply go system.out.print. We're going to use printf so that we're going to properly format our output. Okay. If you noticed on our previous solution, we had a variable to actually store the computation of the energy needed. As I've just said, that's actually a bit redundant because we're actually going to be using that variable once. So you might as well not have a variable to hold that. That way you're going to save a bit of a space in your memory. Okay, so the energy needed is gonna go we can simply put a 4 and then go. Of course, we're gonna have to start with a percentage sign so that the compiler would know that this is actually something that has to be formatted. Okay, we put a 1 after a 3 and then an F, which is nothing else but a format specifier. Okay, with that out of the way, this is where we're actually going to be putting our computation. So the formula, as you guys can see, is actually M multiplied by final temperature minus initial temperature multiplied by that constant 41.84. 4,184. Okay, if your memory serves you well, you would remember that on our previous solution we had a constant which was actually named a formula constant. What I was actually trying to do there is to make you guys better understand that at some point you might want to create constant, even though on that exercise it was actually unnecessary. Okay, now that I've said that, let's actually try to run our program. But before we do, let me put this computation. It's actually water weight. We multiply that by the difference of final velocity. Why do I keep saying velocity? Final temperature. Final temperature minus the difference of final temperature and initial temperature, and then we multiply the whole thing by this constant here, 4184. Now it's time to actually hit the run button and see what we have. Let's try 55.5 and 3.5 And lastly, we put 10.5. Boom, we got it. As you guys can see, we got the very same variable that we got on our sample run. Oh, take a look at this. Actually, I declared this variable even though I wouldn't be needing it, so we might as well take it out. But the program will still work the same. That's pretty much it for this tutorial, you guys. And if you haven't yet subscribed on my channel, I would really appreciate you. That way I would be able to be qualified to some of YouTube features, because at the time of this recording, I'm not yet eligible to do some of the things in YouTube. For instance, I cannot be able to put a link on this textbook we're actually using. So I would really appreciate if you help me out by hitting the subscribe button. Again, lastly, I would really love to hear your opinion on this solution, because some people, they would go as far as to say this stuff is a bit repetitive, but like as a beginner, I strongly suggest you follow this tutorial, because there's tons of mistakes that I go through on this channel. Again, let me know what you think. You can put a thumbs up if you think this stuff is giving you is of value to you. You can also put a thumbs down. You gotta feel free. It's not like you gotta like something that you actually not into. That's pretty much it for exercise 2.10, you guys. See you when we actually do exercise 2.11. Cheers, you guys. I'm gone.